Unit 6, Lesson 6. Go ahead and have the handout and your calculator ready. We're going to try these first 3 questions, pause the video, and then check the video for your answers. What is the sine of theta of the angle 11 pi over 6? So again, sine means your y coordinate here. We can check the unit circle and find 11 pi over 6. Okay, 11 pi over 6 is at the 4th quadrant, and my y coordinate here in red is negative 0.5. Again, I can use my calculator, which I'll use for the cosine this time. So cosine 11 pi divided by 6, which will be my x value of that coordinate. So our sine is negative 0.5. Our cosine is 0.87. What would the tangent of sine of theta be? So if I think of this triangle here, so here's my unit circle, my point is over here, okay, and I've got 0.5, 1, 0.87. Tangent is always the opposite over the adjacent, which in this case would be, the opposite would be that negative 0.5, the adjacent would be 0.87. Or we could say this without our picture, the sine of theta over the cosine of theta. But what would happen if we didn't have our unit circle? Or maybe the angle is not on this unit circle that it gives us. How could we find these values of sine and cosine? Well, let's take a look at this first example here. I'm going to draw a quick sketch. So the sine of theta is 0.8, which means it's positive. It's either in the first quadrant or the second quadrant. It's located in quadrant 1. So we're going to put right here, that's my y value. I don't know the x value. So this is 0.8. This is 1. Again, we've got that unit circle going on for us. Okay. I need to find that x value, or the cosine of theta. So I can set this up that 0.8 squared plus x squared is 1 squared. And I can use Pythagorean theorem here. Oops. Take away 0.64 from 1. We get x squared is 0.36. And then take that square root. And we get x is 0.6. Or the cosine of theta is 0.6. What would happen if the point was in quadrant 2? So that means it's over here. Well, it's still the same triangle here, but now the cosine of theta would be negative 0.6. So it's really important that we know which quadrant it is, because that will determine the sign, the positive or the negative value of our answer. Go ahead and pause the video and try example 2. Hopefully you tried example 2 on your own. It always helps to make a quick sketch. So again, cosine theta means our x coordinate is negative 4, and we're located in quadrant 3. So I'm going to draw a quick sketch. Here's my circle. I am going to be negative 4, quadrant 3, somewhere over here. Draw my triangle in. Okay, again, negative 0.4. I don't know my y coordinate. My hypotenuse is 1. And I can set up my Pythagorean theorem. And I get 0.16 plus y squared equals 1. Take away that 0.16 and I get 0.84. Take away the square root. And I'm going to use my calculator for that. And I get 0.91 as my y value, again, I'm in quadrant 3, so that means sine of theta is negative 0.91. What would happen, again, if the point was in quadrant 2? Again, in quadrant 2, the x value is still negative, so here's my circle. I'm up here somewhere. Okay, there's my triangle. I can redo everything if I want to, but what I should know is that my y value, or the sine of theta, is going to be a positive 0.91 instead. All right, here's another example. Pause the video and see if you can find the cosine of theta and then find the value of tangent. The sine of the angle theta in quadrant 4 is negative 0.6. So again, my y value is negative 0.6. I can draw a quick sketch. So I'm down, here's my circle, down over here, here's my triangle. Getting kind of sloppy with it now. Finding my x value or my cosine of theta and set up my Pythagorean theorem. So x squared plus negative 0.6 squared equals 1 squared. Again, at any point, pause the video, try it on your own, and then check. X squared. I'm going to take away that 0.36 and I get 0.64. Take away, or do the square root now, and I get x, or cosine of theta. And now this is where I need to think. Do I want a positive value or a negative value? I want a positive value here. It will be positive 0.8. How do I find tangent? So going back to my triangle here, I'm going to put that 0.8 in there. Here is where my angle is. Tangent is always the opposite over the adjacent, which in this case is negative 0.6, that's opposite, and adjacent is 0.8. And I can put that in my calculator, 0.6 divided by 0.8. I know my answer is negative, even though I forgot to put it in there. Math, enter, enter. And I get 3/4, so negative 3/4. I can also think of this as the sine of theta over the cosine of theta. Okay, pause the video and try example 4. The cosine of the angle, so again, the x value is negative 0.3 and in quadrant 3. So here's my circle, down here in quadrant 3, set my value up, so negative 0.3, looking for that y, 1 is our hypotenuse, oh, not x. So I got negative 0.3, and it's really important when you put that negative 0.3 squared in your calculator, you put that in parentheses, or you just need to remember negative 0.3 times negative 0.3 is always a positive value. Take away that 0.9, I get y squared is 0.91. Take the square root now, and I get that y is going to be, oops, a 0.95. And in this case, the sine of theta will be negative 0.95 because I am in quadrant 3. Okay, that's where my angle is. The second question is, what is tangent? Again, tangent is the opposite, so negative 0.95 divided by negative 0.3. A negative divided by negative is a positive. 0.95 divided by 0.3 gives me 3.16, or we'll round to 7. Okay, all right. Quick review to just wrap up everything that we've been doing up until this point. Any point on the unit circle has an ordered pair of cosine theta, sine theta. If we know the cosine or the sine of an angle, we can find the missing value by using the Pythagorean theorem. And again, that's going to be cosine theta squared plus sine theta squared equals our radius of 1 squared. The tangent of an angle is sine theta over cosine theta, or the opposite over the adjacent. Okay. And then this was a concept we talked about on Friday. We just touched on it. And so I just want to review here. It says angles can be located at the same location, but look differently. For example, the angle pi over 4 is located at, let's look at our unit circle. Pi over 4 is at 0.17, comma 0.17. What are some equivalent angles that are located at that location? So when we mean by equivalent, that means we have to land back on that spot. So here's this angle right here, that pi over 4. What this is saying is that if I start here and I just go that amount, I'm pi over 4. But what happens if I go all the way around and then in that amount? Well, that means I did pi over 4, that little amount, plus a whole revolution, which is 2 pi over 4. And I could put in my calculator 1 divided by 4 plus 2, and that gives me my fraction of 9 pi over 4. I could also go around the circle more than once. I could go pi over 4, 1 revolution, plus another revolution. So I could go pi over 4 plus 2 pi over 4 plus another 2 pi over 4, or 2 pi, sorry. So I can go 1 divided by 4 plus 2, and then change that to a fraction. And I could get 17 pi over 4. What happens if I were to subtract pi over 4? I would go the other way. So if I look like in purple, I would go this way, okay? I would go all the way around this way, okay? Well, I can take pi over 4 minus 2 pi. So 1 divided by 4 minus 2. And then that would give me my answer of negative 7 pi over 4. Hope this video helped. Make sure you come in tomorrow with questions.